Good morning everyone, and happy Thursday, nearly end of the week. My name's Robin, I'm the Technical Director of Man & Machine UK. I'm here this morning with Simon Brand, our Manufacturing Sales Manager, to talk to you about BIM for Manufacturing. Interesting session certainly for me this morning because of all the technology that I'm surrounded with. Because this morning is actually the first time that we're running one of our M-Word YouTube live sessions on YouTube Live, so good morning YouTube. As well as one of our registered webinars for our clients, where they come and register for one of these sessions. So good morning to our clients through Zoom as well. Hopefully I'm nice and clear and you can hear me okay. I'm sure someone will either shout or throw something at me or leave me a comment if that's not the case. But a very good warm welcome, very good morning, and a nice warm welcome to all of you. So just to get the niceties out of the way to begin with, I guess, for those of you that don't watch these sessions every Thursday, we're usually live at 2 p.m. in the afternoon where we run our M-Word sessions. We broadcast on all of the social media channels as you would expect, and we run these sessions really as a virtual coffee break to present a new technology, a new feature, a tip, trick, some industry topic, or something that we feel may be of interest in either the manufacturing space or indeed the construction space, as well as we are cross-discipline. Today's session's quite nice because it's building information modeling for manufacturers, so naturally it's touching both sessions, which is fantastic. The sessions are always recorded, they're streamed live, they're put up on YouTube afterwards, so by all means, if you're not following us already, head to our YouTube channel, give us a watch, give us a like, give us a subscribe, and hit the bell to turn on notifications so that you can see when we go live. And actually for today's session, that's a good point, because if you head onto our YouTube channel, there's a good 2 or 3 videos for previous sessions that we've run for BIM for manufacturing. One of them goes into a lot of technical detail around the standards and the specifications. One of them goes into a lot more detail about the technology. And today is kind of going to be a mixture of both. But I'd recommend that if you haven't watched it already, go and check us out on YouTube, search for those older videos and rewatch them. Or indeed reach out to myself, or Simon, or one of the other guys that you're already in contact with, and we can send you those videos directly. And finally, give us a comment, leave us some feedback, tell us what you like, what you didn't like, and what you want to see in these sessions moving forward, because naturally we want to make these sessions for you, both our clients and our subscribers, so let us know what you'd like to see, and we'll be more than willing to tweak and adjust these sessions to suit. But without further ado, I hope you've all got a coffee. I certainly have. And I do pre-apologise for any bunged up sound. Hay fever seems to have hit hard this week, so I apologise for any nasal sounds during this presentation. But nonetheless, without further ado, I'm just going to shrink myself into the corner and share my screen. There we go. And we're just going to start off in PowerPoint, just to run through a few exploratory slides, or explanatory slides almost, to try and set the tone and explain the differences between different types of manufacturers and how they may need to engage differently on a construction project, or indeed in the wonderful world of building information modeling. So we're going to start with that, and then we'll jump into some technical demos using both Autodesk Inventor and Autodesk Revit and the Autodesk Construction Cloud, and showing you how all of those features, all of those tool sets link together really nicely now in the 2023 releases. And then Simon will finish us off at the end of the session and talk to you about some next steps. So, if we can just get my clicker working, which would be a really good start. Serves me right for having so many screens. There we go. I want to start by talking about technology, actually, not in the sense of Autodesk technology or design technology, but just in general. Because if you look at what's happening in industry, and this is on both sides of the fence, in the manufacturing industry and in the construction industry, everything's becoming more connected. We in our daily life, we're using our mobile devices and the internet more often than not. If you think about how you watch a film nowadays, the likelihood is you go online to a streaming service, or you go onto your Android or your Apple TV and you stream a film, whether that's through a subscription service or whether that's through a rental or a purchase. When we do our banking, when we book a flight or a train ticket, typically it's all done on the internet nowadays. Gone are the days where we go and physically sit inside a travel agent and look through books and books or pages and pages in magazines to pick a location and then a hotel or an area, only to find out, oh sorry, an hour later there's no room at that hotel, we need to pick another one. Those days are all gone, and that's just what's happening with technology in general in our day-to-day life. And because of that, certainly in the manufacturing industry, things like Industry 4.0 are leading on to that, and the ability to give your clients the ability to customize your products and choose customization options before the thing is built, whether it's something like a car, whether it's a consumer product, you're buying a new iPhone and you want some engraving on the back. All that kind of stuff is being driven through smart industry, automation, and really wanting to drive better, I guess, customer integration or better customer involvement earlier on in the process, so that everything becomes interlinked. And really, if you think about what BIM is trying to do with smart cities, with digital twins, it's the same kind of thing, but on the construction industry. So it's all about connecting workspaces, connecting data between different systems or between different individuals that are part of a much bigger project or process. So really, it's the modernization of what we're doing day to day in our day-to-day life that's really allowing these topics or terms to come to the forefront of our working life. If we then strip that back and talk specifically about BIM for a second, and building information modeling or digital construction, the one thing to make really clear is because of all of these interconnected workflows and processes, actually the biggest importance of what we're doing in this interconnected world is not necessarily the thing that you see. It's not the visual representation. It's actually the meat behind it or the information behind it. So I've actually stolen a few slides from our BIM Ready training content from my colleagues Richard, Gareth and Mark, which hopefully they're okay about. But I really like this slide because it explains very visually that exact point. So when we look at digital construction, the model, whether we're talking about a Revit model, whether we're talking about a manufacturer's model that I want to send to ArchiCAD or send to Revit or send to Tekla or whatever it might be for a construction model, that visual thing that you can see and spin around is really just the tip of the iceberg, and actually for the most part it's quite easy to do. The bit that's more complicated and actually probably more important is what's underneath that sea level, which is all of the information and data regarding the different standards that you're aligning to, the classification systems, how that particular equipment works, the asset management information for that equipment, so on and so forth. So actually, to get the full involvement or even benefit of digital construction and building information modeling, and it's the same for Industry 4.0, it's looking at that whole picture, and you don't see the value unless you have that whole iceberg or that whole picture. So just providing someone with a 3D model of your component as a manufacturer might not get them everything that they want from the construction industry to place that into their model and use that appropriately moving forward. They might want some information attached to it to get the value or be able to use that in a wider sense. And the reason behind this is looking at the way in which we hand over information. So construction projects are not overly dissimilar from a manufacturing project. If you think about when you have a product and you sell that product, and with that product comes a set of instructions. Pretty much they're all digital download nowadays, but they come with a set of instructions. Much is the same for a built asset. There will be handover documents which are historically physical, on floppy disks, on DVDs, and digital media, but not necessarily shared in the modern way that you would maybe expect to share them. And again, one thing that digital construction is trying to do is digitize and modernize that. So we're not getting company A giving their handover information and then walking away and that's them done. What we identify is within a building, there are a number of managed assets. If you think about air conditioning systems, if you think about lighting systems, electrical systems, fire protection, fire doors and things like that, they're maintainable or managed assets that have a management cycle where they have to be maintained with new filters or new seals around the fire doors or whatever it might be. And because of that, that information that's known up front by the designers who are using the data from the manufacturers is really important or beneficial to the clients. So the idea of this is to bring this digital design world that we've been working in for, a long time now. We've been off the drawing board and actually using digital designing tools that hold that kind of information. It's just sharing that digitally, starting with that end handover in mind. The client wants to be able to see what their maintenance schedules are over the next 7 years for the HVAC system in their new office or in their managed building. And this will allow them to get to that point. Yes, there's a lot of if, buts and maybes in between and standards that you have to follow to achieve these handovers from a construction perspective. But this is the idea, so that we can have an interlinked system and that initial information can build throughout the stage of the project and end up within a CAFM system, a customer, or a BMS system within a customer, or within a common data environment that houses all of it. And that's the idea behind that digital handover. Now, if we look at us, and I'm playing the part of a manufacturer today, so if I look at what we need to do as a manufacturer, is essentially provide both non-graphical and graphical information to the construction industry. And that comes in a couple of parts that I'll explain in a second. But sometimes those might need to be interlinked or parametric, if you want to call it that from a manufacturing standpoint, or even updated throughout the course of a project. But generally speaking, as a manufacturer, there's going to be products that are used in the building industry. I will take a light fitting because there's one right above my head. For example, you might be asked to provide a BIM model of that light fitting, and that would need to be both graphical and non-graphical. So a 3D model and the information behind it as well. But actually that differs dependent on how you're being involved in the project. There'll be some of you on this call or watching on YouTube that do more than just manufacture products. You're actually getting involved and getting your hands dirty on site with not just the design and the manufacture of the product, but also the installation of the product or the design of that product specifically to suit an environment. So exactly what your role or responsibility is will be different. I'll get to that on the next slide. Before we do so, just a bit of a visual about how building information modelling and digital construction in the UK is continuing on its path of growth. So I remember sort of 10 years, even longer than that, 12, 15 years ago, when people were saying that this is a buzzword, it's not going to go anywhere, it's going to phase out. And that just isn't the case. As the UK and the construction industry has really bought into this, previous documents that were guidance documents are now evolved into full-blown international ISO standards like 19650, which came from the PAS 1192 documents. And the same is happening for the standards that we need to align to more from a manufacturing perspective, such as the 8541 series, which is explaining how to manufacture, how to model and add information to your BIM models, for example. They, over the next year, they're due this year, but over the next year, they will transition into another new ISO 22014, which is due at some time this year. So this isn't going anywhere. This is constantly evolving and will continue to evolve with the launch of the UK BIM framework back in 2019, when BIM Level 2 as a terminology essentially was retired with the documentation there. We now have the UK BIM framework, and that's really gaining momentum and allowing us to really push this forward. So if you need to understand what standards relate to you as an individual manufacturer or as an individual, then go and check out those previous videos that we've done on YouTube, because they do explain them all. Again, they are all there and they go into a lot of detail about which you should watch and why you should watch them. Also check us out on social media, because we're continuing to work alongside the UK BIM Alliance, specifically with regards to their certification program in the UK. So keep an eye out there for the latest and greatest information. Apologies for the stumbling there, but instead started telling me that my internet is a little bit weak, so I'm assuming everything's still streaming okay. But let's carry on. So to get back to that point of two different types of company, if I can put it like that. Now there's going to be more than just two, but I just wanted to try and pick two very clear-cut examples to try and explain the differences in maybe what's going to be expected of you, or what you might even want to do from your own perspective to ready up for this process. Because in my mind, you've kind of got two clear types of manufacturer. Firstly, you have what I've called a designer and a manufacturer of a product. So you design and manufacture light fittings, you design and manufacture taps, showers, you design and manufacture a window or a door, maybe an air terminal or an air handling unit. It's a product. You just design it, manufacture it, and then you sell it. You don't get involved with any specifics with regards to a certain installation or a certain project. It's just a set product that you design and fabricate. For those individual companies, you will be likely either wanting to or being asked to provide BIM models. With those, you need to leverage the kind of information that you would put on inside of something like Inventor. From a fabrication perspective, it's all singing, all dancing, it's fully detailed, and they can be quite heavy models. Versus what you might need for usage on design intent. So if someone was taking that air handling unit and they wanted to place that inside of their Revit model, for example, what information would they need to see versus what they wouldn't? Well, they certainly wouldn't need to see any vents or perforations in the unit for cooling or for flow or whatever it might be, but they'd need to see the size, the shape, certainly where the inlets and outlets are, any electrical connectors as well as the pipe connectors, so on and so forth. They might want to see where you've got mounting locations, or if there's anything specific about those mounting locations, center of gravity and stuff like that. But you've got to look at what they actually need. They don't need to see every chamfer or every fillet or every finite piece of detail, and certainly not what's on the inside of the unit. So we can do a lot of simplification to get those components more friendly for the software that they'll be used within. Inventor, you're modeling one of them. You model it to fabricate it, so it's fully detailed. If you take that HVAC unit and put it into a building, you're going to have tens, if not hundreds of those units around a building potentially, depending on the size, naturally. But with those, the more you have and the more detail, it will slow the model down. It will make the people using them not want to use them, and it will become a hindrance. So look at what you need versus maybe what someone that's placing that in a design might need. That links directly to the level of detail and the information. It's all related to the same thing. But again, remember what I said earlier, it's not just that model that you can see and touch, it's the information that's attached to it as well. And because of that, we need to align to certain standards or product data templates, which I'll show you very specifically in a second, as to how we can understand what might be required of us or what we should do as an individual. On the other side of the fence, you've got those companies that are a little bit more involved. For example, someone that I've put down as a company that both delivers a design and manufactures a design, but they then deliver that against a CDP, so a contractor's design package, for example, where they're actually being involved on a project. So as well as designing that HVAC system or that HVAC unit, that fan coil unit, that air cooling unit, whatever it might be, as well as designing that and manufacturing it, they're also then designing the system for a building. They're placing that system in the right place within the building and getting involved with the project side of things. And whilst I've used the HVAC example there, you might be a manufacturer of a rolling shutter door. And that rolling shutter door is very specific because it's got to be in a warehouse in a huge distribution unit. Or it might be that you have very specific fire doors or cladding, as the example that I've got in the background here. Oops, went too far on. Or some cladding, where you're a specialist designer, you manufacture that cladding, but it's very specific to the project or the building. Therefore, you get involved a lot more. Those two different individual companies will have a lot of differences with regards to what their responsibilities are. I've explained the ones for the individual product manufacturer, but if you look at those specialist designers or subcontractors, they're going to have project design responsibility. And because of that, it's important to note that there will likely be contractual obligations within those CDPs. There's going to be a BIM execution plan against and exchange information requirements. There's going to be some asset information requirements. And as a manufacturer who both designs the product and then places it in the building and designs around it for that specific purpose, you're going to need to read, digest and understand those and the whole ISO 19650 workflow to make sure that you are delivering what you're signing up for at the end of the day. Again, I don't want to get too in depth with that side of things today, but reach out. We've got some very intelligent people on both sides of the business here in both construction and manufacturing who are very well versed in the UK BIM Alliance, the UK BIM framework, and all of the different standards that they relate to. So please come and talk to us, and we'll be more than happy to point in the right direction. Okay, so with all that in mind, what are my options? So whichever side of the fence, as I've put it, you sit on there, you need to understand the standards that relate to you. I've not gone through them all today. Check out the previous videos on YouTube or give us a call and we will point you in the right direction. Generally speaking, if you're working on projects, you're going to need to understand the whole ISO 19650 suite, as well as the 8541 series and what have you, to make sure that you're modeling and delivering against that project in the correct way. If you're just a manufacturer and that's it, I've manufactured the product, here's a BIM model, then you might want to identify and understand 8541 because that will tell you how that BIM model should be and look. You might also want to understand things like ISO 19650 Part 4, which is about the BS 1192 Part 4, ISO 19650 Part 4 will come out later, which will explain COBie and asset information and how you need to align your components to asset requirements on a project. But reach out if you need more information. Leverage the technology that you have so that any processes that you have to follow and that you appreciate will become easier. And I'm going to explain and show some of those through Inventor, Revit and the Construction Cloud in just a second. Understand your project role. So as I said earlier, try and recognize what side of the fence you sit on so that you know whether you're just providing a model or whether you are actually getting involved with that from a project perspective, and approach us if you need help. So without any further ado, I'm going to stop talking and I'm going to start jumping. I'm not going to stop talking because that'd be silly because then there'd be no narration behind the video. I'm going to continue to talk, but I'm going to start talking about technology rather than going through PowerPoint slides. But actually the first thing I want to do is just open up a resource on the internet, which is the MBS. So let's just jump onto Edge, which I'm pretty sure is going to go on the wrong screen. So let's just bring this over here. And what we're going to do is just search for the MBS definitions. So what we can do on the MBS is we have a toolkit. This MBS resource is going to explain to you about different standards and different classification systems. So for example, in the UK, if you're aligning to the UK BIM framework, we will use Uniclass 2015 as our common classification system for components. The MBS BIM Toolkit will allow us to search through those definitions and identify A, what classification code and description I should be using, but B, what level of information and level of detail I should be aiming for that particular type of component. And all I'm going to do is just pick a very generic example for the purpose of this. Maybe we'll search for air handling unit, as I've given that as a couple of examples. I search the definition on here, and this will give me a load of different results based on whether I'm looking at a product or a system or an entity, so on and so forth. Again, if you need to know more at that level, please give us a call. But in this case, if I'm developing an air handler unit for the supply of air, I can see that I've got an object here. If it's a supply and return, I can see I have another one. And I have very similar Uniclass classification codes with a slightly different end. Those codes are hierarchical, so they're all linked back to the same top level. But if I just select a generic supply and return, what this will do is it will start by telling me this is your unit class number, this is your unit class description, and then here is the level of detail that I would be expected to produce from a building information model or a digital construction model perspective. Okay. Level 2, it's a box with some dimensions. Level 3, it's a box with some duct connectors modeled. Level 4, it's got a bit more detail about the pipe connectors on the side and maybe the electrical connectors, but it's very much still a box. And number 5, again, it has maybe a bit more information on there about what that sits and looks like. But still, from a manufacturer's standpoint, it's a very simple model. It's an envelope. And alongside that envelope, you have this void here, which is showing this free space that you cannot take up alongside that component because of maybe access for changing filters in this case, or maybe access to actually install the pipes, or it might be heating and cooling reasons. Either way, it explains what you should be looking at both in a 2D and a 3D design. If we then go to the level of information, it will show us the level of data that will need to be applied against each of those numbers. So at 2, it's just a description, as it is at 3. If we go to level of detail 4 or level of definition 4, we then have all of these, and that just grows as we continue. 5 will introduce the Kobe data. 6 will introduce the Kobe data. So there's a great deal of different parameters there that exist. Okay. Again, if you don't understand any of this, please reach out and we can strip it back and make it understandable or digestible for you. As well as that, and giving you that in black and white, because if you're being asked for a BIM model as a manufacturer, I would probably aim for, if I was just supplying it as a bog standard manufacturer, I'd probably aim for 4 or 5, if I'm honest on here. You might even go in and put all the parameters in for 6, just because you can, but that's kind of what I would aim to do. Alongside those, if you go to your manufacturer's product data templates, you can download a little package here. It's going to ask me to log in. I'm going to see if I remember my password. If I don't, then I'll give it a few tries. There we go. So if I download this manufacturer's product data template, again, this is a free resource, so whilst I have a login, you don't need to pay for this. This will download a zip file, and inside that zip file, we have an Excel sheet. And that Excel sheet will reference and link all of the information that you would be expected to provide against your models from a manufacturing perspective. And depending on what you're modeling, that will either get bigger or smaller. So it's a great resource if you're new to this, if you don't quite understand it, have a look on there, link what you're looking to, what you produce to one of those definitions and start building it out. But by all means, come and ask us a question. Now, what I'm going to do first of all is we're going to start off on the side of the fence that's more involved with projects. So let's imagine that I'm in a joinery company and maybe we do specialist fitted kitchens or built-in wardrobes or whatever it might be that are very specific for the building that they're going into. Because of that, I'm getting more involved in the project, so I probably have more specific handover requirements or contractual requirements or obligations on that project. So what I'm going to do is just explain some of the new functionality inside of Inventor and Revit 2023 that's going to really help you in that scenario. I'm logging into the Autodesk Construction Cloud, specifically Autodesk Docs. Autodesk Docs is a common data environment that's cloud-based that allows you to manage your projects in a cloud environment. Many contractors, many clients, many architects and design houses are using this now to manage and share and collaborate their data on building information modeling projects. Because of that, and it's also an Autodesk product, Autodesk have leveraged a link between this cloud system and Inventor from a manufacturing perspective. So if I come into my document management area within this dummy project that I have set up, what I can do is show you that I've uploaded a Revit model for this particular demonstration. This is a standard Revit model. This functionality only works at the moment with Revit 2023 releases, so that's important to note as some projects are running on older versions of Revit. But what this allows me to do on the web is we have a simple building with this particular project, and this is a multi-use building that's got a mixture of retail, and it's got some flats in there as well. On the ground floor there's a flat, and I've got this this kitchen area here that the architect's just put that together, but actually he wants to send that out now to a joinery company to get maybe a more modern or a more fitted or specific design. So that's what we're going to play the part of today. So we can come on and view this on the cloud. We can start taking sections and having a look at this. But actually from Revit, we can start producing and publishing collaboration views, which is maybe just showing me purely the information that we want as a manufacturer. We're caring about that one space or maybe a few different spaces. We don't care about the whole building. So we have these collaborative views. And then either the contractor or the architect or the structural engineer or whoever is typically the main designer on that project can create these data exchanges using that cut down collaborative view. What that does, if I just jump back into my folder structure here, is it gives me this collaboration data exchange file. If I just minimize this and jump into Inventor and say collaborate, data exchange, what this does is it taps into Autodesk Docs. You need to have a license naturally, so you'll need to be assigned a license either by your Autodesk administrator or indeed by whoever is driving that Autodesk Docs workflow. It works both ways. You can either use their licenses or bring your own. But this connects up and we can see in that project we have our collaboration view. I'm going to select it once and say preview. This will just open the Autodesk Forge viewer, which is a fantastic cloud-based development platform to enable you to customize and develop the products for further customization. We can see it's the same viewer that we basically just used on the net. So we can come in and start sectioning this and just having a little look before we get it into Revit, Inventor, sorry. I'm happy with that, so I'm just going to load it in. And what that will do is it will pull that data from Autodesk Docs into Inventor. Now, this should be pretty quick. I'm on a fast machine. We've got a fairly good internet connection here, but I am streaming over several channels at the same time. So we'll just give this a couple of seconds to import. And then what we'll end up with is that cloud model sat inside of Autodesk Inventor. It looks much the same as what it looks like inside of Revit. And we can see that it's the same view that we've just been interrogating online. If we look on our browser, we have our cloud icon here. That's a live link. If this updates on the cloud, Inventor will pull the latest version, which is great. So we're constantly collaborative. All I'm going to do is select the existing casework here and just right click and turn it off because I want to hide that so I can place my specific casework in its place. I'm going to go to a right view and just use some standard Inventor functionality to select any parts in this corridor. I don't need them. I do need the floor. We'll leave the floor turned on and we'll leave this wall turned on, but everything else we can right click and turn the visibility off. We'll just do the same thing with this, this top area here. We don't need anything up there. We don't need this wall or this television screen, and actually I don't need the ceiling for the purpose of this. I'm not going to do anything at ceiling level, so I'm not that fussed about leaving that on for collaborative purposes. So I can customize this view further if I want to inside of Inventor. But these are all picked up as Inventor parts. I can't edit them because they're Revit geometry. If you're wanting to get an editable workflow, there's other routes that you go down, which would be importing the model from Revit and being a selective import. This is for collaborative workflows, so these are displayed as parts, but they're non-editable. And then from here, I'm just going to put on a quick save. I'm going to say save, hit OK. I'm just going to save this as BIM for MFG and hit save. Now, I've developed a simple iLogic script for helping me with the placement and the editing of this casework. I'm a bit conscious on time. I don't want to spend too long doing something that's actually relatively simple. So it's quite a simple cabinet that I'm going to place. But I'm going to use some iLogic, which will allow me to place a template cabinet and then change the size of it very, very quickly within this assembly. It's not going to automate any constraints or anything like that because it's important that you see that the Inventor workflows exist as they do normally. So it doesn't matter whether you're using automation in iLogic to place components or if you're just modeling on the fly. Even modeling as a multi-body part would work. All of your standard Inventor functionality works really well. I'm going to go to my iLogic tab, open up my layout builder, and I'm going to say add a cabinet. I'm just going to close that down, and that adds a simple excuse me, floating cabinet over here. I'm going to just use good old-fashioned constraints and constrain the feet of my cabinet to the floor. That is the Revit floor, remember. Use the curvature of the Revit wall to constrain the back of my cabinet. I'm not going to bother leaving any gaps. We're going to flush to the wall. And then maybe for the purpose of this, we're just going to build a few cabinets off the door just to show the workflow. So let's grab the side of the cabinet and link that to the door with a 50mm offset. You'll notice by default when you're working in this way, it will default to a larger size. So make sure you check your templates if you're working with this. So let's go 50mm away, hit OK. And then using that cabinet, I want that to be a double cabinet next to the door. So let's go, I don't know, 1000 wide. That's about the size of a double cabinet. Happy with the leg height there, happy with everything else. Push those parameters to that cabinet. Brilliant, that's updated. Let's add another two. So add a cabinet, ignore the message box. Add a cabinet, ignore the message box. So here's my two cabinets that I've now added. I'm just going to do exactly the same thing. Just bear with me while I constrain them up again. So let's put them on the floor. Again, we'll constrain them to the wall. So nothing that you wouldn't ordinarily be doing, but rather than, oops, that's not the right first selection, sorry. Rather than maybe modeling some generic geometry here for these walls and things like that, we can just make the most out of this functionality. I think it works really well. So there's the second cabinet, and then the third one, floor 2 feet. Really need to turn off the constraint noise that happens in Inventor. Every year I forget to turn it off, and every year I sit throughout the whole year doing these sessions moaning about the noise that it makes. Why I don't just turn it off, I don't know, but maybe I like it. Maybe I secretly like it. There we go, to there, perfect. So there's my 3 cabinets, which are fully constrained to the floor and the wall. And you'll notice that they're specifically placed. I'll come back to that shortly. Let's just update them individually. So let's say that we've got our double pack here. Maybe next to that we want a draw pack. So they're roughly, give or take, 300 or so. Let's push them to this cabinet. It gets rid of the middle support bar and gets that ready to accept a draw pack on the inside. And then this one, I just want to be a standard single pack. So let's update that. Maybe that'll have a built-in cooker. So great, we've got our components there and they're placed. I'm just going to put another save on, just to make sure it saves those changes before I export this out for then using inside of Revit. So generally speaking, we'd go through our normal process, placing components, building specific components from scratch, creating drawings, what have you. But then the magic comes, because I've now got these components which are placed. Okay. If I say model, and I'm just going to turn off the visibility of this collaborative view for the moment, because I'm going to do an export and I don't want that there on the export. And just to show you that inside this model, much like you always have in Inventor, you've got this origin. And you'll notice that that origin is not too dissimilar to where it would normally be. Now, a Revit model, when you draw it in Revit, you have coordinate points, especially when it's a digital construction project. It will never sit around 0, 0, 0. When you're working on a construction project, you use real-world coordinates because you need everything to fit together and work. We just don't work like that in Inventor. It would be ridiculous to model something 20, 30, 40, 50 miles plus away from the 0, 0 point. And quite frankly, Revit Inventor would have a heart attack. It wouldn't know what to do with it. So what I'm about to point out is really, really key. These were modeled at the right point on the building, which had very specific coordinate points set inside of Revit. What I'm going to do now, I'm going to be a bit naughty. I'm not going to simplify anything. I'm going to go to my Environment tab and start my BIM Content tool. Now, this is a tool that you can use whichever side of the fence you sit on, whether you're wanting to publish models as a manufacturer, full stop the end, or whether you're wanting to publish models that a design team could use inside of Revit, inside of ArchiCAD, inside of Tekla, or any other BIM authoring tool that's out there. And we're going to do that process first. If you were an MEP component, you would define where your connectors are and what those connectors were, the voltages and the flows, for example. We can go in and author the building components if we want to, but only to Omniclass. That's a bit of a shame from my perspective. Inventor only points towards Omniclass. I guess that's a little push for the developers to put Uniclass in their please, thank you very much. But we can classify these components if I wanted to. Again, I'm not going to do that today, right now. I'll show you that in a second. We can include model properties. Again, I will show that in a second. I'm just going to export these straight out. And I'm going to export these out to IFC. So let's save this on the desktop so I can find it. And let's hit save this out, IFC 2x3, hit save and say yes. It takes a couple of seconds to export this out, but the IFC file format is an open format. It's not Autodesk specific. It's an open file format that's owned and pushed by Building Smart, and it works really well with all of the BIM authoring tools. With those components now set, I'm going to go into Revit and open that very same cloud model from the Autodesk Construction Cloud. And what we're going to do then is link in my that Revit file directly that we've just exported. So let's go to our ground floor plan, and we can see here is our kitchen ready for information. If I say insert, link IFC, I can go to my desktop and grab this BIM for MFG file. It looks a little bit small. I'm hoping it's exported correctly. Let's just choose to place that. Give it a couple of seconds, and we can see not only does the geometry come in, but we place that geometry on the floor, on the wall, and 50 millimeters away from the door frame. This building is not at 0, 0, 0. This building, if I go and select the coordinate point over here, the survey point, it's not a million miles away. It's a sample model, so it's only just off the axis. But you can see this has northings and southings, eastings and westings, and an elevation. I don't think it's got an angle to true north on this one, but you can see the collaboration and the coordination works well between the products. And whether you are looking at those products inside of 3D or 2D, we can see them, they exist, and they are positioned exactly where they need to be. And actually, they come across really nicely inside of the Revit system as well. Okay. Yes, they're a bit boring. I could have put some cupboards on the front of here. I could have put the drawers in there and a nice bit of granite on top. But that doesn't show you what you need to see, which is, doesn't matter what it is, does it go in? And most importantly, does it go in the correct place, which hopefully you can see it does. That process, I've done it locally just to save the upload and download, but generally speaking, I would have uploaded my IFC file then onto the construction cloud, and that would have been linked and updated and refreshed for the rest of the project team. But the process works extremely well. Not only that, again, I'm not showing it today, but remember the parametrics there. If I move this door in Revit, re-upload it to the cloud, update my data link file, I had a constraint there in Inventor that was 50 mil. If the door moved, the constraint would move with it. So you get your full parametric workflow with that interoperability, which for me, that's fantastic. I think that works really, really well. The only other workflow here is if I jump back to Inventor, and let's imagine that we are a manufacturer that doesn't get involved in projects. We just make these cabinets. That's it, full stop, the end. How do I go about creating those BIM objects or BIM models for the people that need them, either off my own back because I want to put us out there as a company that is aligning to that, or because I'm being asked to. Let's just finish this content and close down this file. And what I'll do is I'll just open up my master cabinet here, like so. Let's just zoom extents. So there is my master cabinet. Again, it's not too exciting or pretty, but you'll get the general idea. Now with this, there isn't really anything in here that's complicated, but if I go and have a look at the feet, we do have some grippers here and some things that we might want to turn on and off. So what we have inside of Inventor, both inside and outside of the workflow, is this Simplified tool. If we start it here or start it through the BIM content environment, it doesn't matter, they both do the same thing. But when I go to Simplify, I get a load of options. So all of this on the left-hand side here has been built on over the years. We used to have a tool that was called Shrink Wrap. This is now what we have, Simplify. It does the same thing, but with a lot more intelligence and a lot more parameters associated with it. So if I go to Import, I can tell it what model state to use in Inventor, what view to use, and if I want a positional representation. I can replace objects with envelopes. So I could say, do you know what? Replace every part with an envelope. It will go and identify parts that remain because of other rules, and it will replace them with an envelope, which will be like a box, for example, or a sphere, or a cylinder. So what I'm going to do is I'm going to just say no to that. I don't want to exclude parts by size to bring those feet back, but I want to choose every part and turn it into an envelope. You'll get an idea there straight away of what this is doing. We can be more selective if I want to and just say go all in one envelope or every top level component, depend on the size, depends on the size of the individual files that you want. But we can choose all of them and tell them to go into an envelope. It just sets them all as single bodies, which is great. We can also remove features. So we can say go and remove all fillets, go and remove all chamfers, go and remove any pockets that you find that's greater than let's put that on 250, that's greater than 250. Go and remove any embosses, go and remove any tunnels. We can go and get it to highlight features then that it's going to remove. And we can say, brilliant, it will get rid of those. Great. I still want the feet on there, but I want to remove these fillets and chamfers that it's found. Finally, how do you want it to output that? Do you want it to output it as a part? Do you want that to be a substitute? Do you want to give it a name, a BOM structure, so on and so forth? We can have advanced properties that might send this out to, or just disappear off the bottom of the page. Little bug there. Advanced properties to keep that linked, break that linked, rename it, so on and so forth. I'm going to leave everything as default and just say OK to simplify that model, to basically turn off the information that was around there. With a more complex part that had nuts, bolts, washers, it would remove all of those, fill the voids, and actually make a really good job of that for you. Okay. Once I've done, we define any connectors. This is a piece of wood, it doesn't have a connector, but we define any connectors that we need. We then author the building component and define it inside of Inventor. Although this is Omniclass, it's still important that we do it from Revit's perspective. So I can search in here for a cabinet, hit search. We should be able to filter down this list and find casework components cabinets, for example. Okay. Again, apologies that that's Omniclass. We're limited to what the developers give us there to a certain degree. Hopefully they'll implement Uniclass at a later date, but either way, it's important to do it from a Revit perspective. We can then include model properties. I haven't put any BIM data in here at all. I've been a little bit lazy, but if we wanted to add BIM data inside of Inventor, we could. Note that this is just picking up iProperties. Okay, some BIM data, as we saw at levels 3 and levels 4 earlier, just ask for a description. So we could say a 18mm wooden cabinet. Manufacturer, Rob's Cabinets Limited. www.ineedcoffee.com. There we go. Hit apply. We can add some properties. From your perspective, all you need to do to make this compliant with BIM information mandates or requirements, just go into iProperties, go to custom, and add all of the ones that you saw on that MBS site earlier. Okay. Download the product data template and add them all. So if I wanted to start adding parameters for warranty duration parts, warranty duration unit, which are Kobe parameters, go and add them, and this will pick them up. Once you're done, export the building components. Again, I'm going to throw out my desktop just to make it easy to find. I'm going to call it kitchen cabinet. Don't go out as an IFC. If you're creating components, don't use IFC. IFC is for a project file. Okay, like what we did earlier, the entire kitchen, that would be an IFC. Or the facade of a building, that would be an IFC. The entire MEP design for a building, that would be an IFC. A cabinet is not an industry foundation class file, okay? So you want to pick either an RFA file, Revit family, or you could use an ADSK if you want to. I'm going to go to a Revit family, hit save, hit yes, give it a couple of seconds, and then I should be able to go into Revit, choose open from the desktop. Let's just close those down, bear with me. did you export? That's the IFC. Where did I put you? Do that again. Export building components on the desktop. Pick me. Save. Yes. Looks like something failed, which is good. The demo ghost got me. Okay, I'm not going to beat around the bush. Let's just go out as an ADSK file. Something bizarre going on, probably because I've got Revit open or something like that. Let's give this a couple of seconds. Push out to ADSK instead. My apologies. Let's go and open Revit and start a new file and say that we want to place a component, load a family, and then we can find our designs, which is C drive, Vault, designs. There's my file. Open it up. There is our component inside a Revit. If we go and have a look at that component, we can see it looks very much the same. It has the simplified legs on the bottom. And if we go to edit type, any properties that we told it to come through, like manufacturer, the URL, and the description, all come through as you would expect them to. An architect or another Revit user could then pick that up and start using it quite nicely inside of their system. And I think that's all I wanted to show. So let me just close down Revit, close down Inventor, and get back to the PowerPoint. So I'm going to say thank you very much and toodaloo. I'm going to hand over to Simon, who's just going to take a couple more minutes of your time to finish up and explain the next steps. So just bear with me while I sort out the camera. I'll just turn it off while we swap over, and then we'll be back in 2 seconds.
Thanks, Robin. That was really good. Thank you very much. Really great presentation. I mean, I know a lot of you that I've spoken to in the past about BIM for manufacturing have struggled over the years. I mean, it's been around for 10 years or so, the construction industry have been talking about BIM, and we're still in the same position. Although it has evolved, I think a lot of you as manufacturers have become, should we say, rather frustrated with the pace of change and understanding what you need to do. Now, what I've noticed and what Robin's been talking to me about more recently in recent years is not only the industry seems to be getting its act together a little bit in terms of the certifications, in terms of the process itself, but also it's great to see that Autodesk are really finally integrating properly Inventor and Revit, and that interoperability between the two products is wonderful. And one of the things that I've noticed over the years is that a lot of you, maybe if you're doing single products like Robin was talking about, you may start off with asking an external contractor to go and do that for you to create this single model for this particular project. You may evolve into the point where you need to do a number of them. So in fact, maybe it makes sense for you to look at buying Revit yourselves, or perhaps using the BIM Exchange or the Simplified tools that we've got inside of Inventor. At some point, if it's something that you need to do on every single project, one of the things that really excites me personally, and Robin showed a little bit of it earlier, is iLogic. Now, iLogic is our automation tools, and the thing that really gets me excited and makes me passionate is the idea of automating these processes. And your designers are very good at using Inventor for designing their products. BIM is a requirement. Now, why not make it so that in the background, every single model creates a BIM model in the background? Now, that's something that we've done on several projects with several customers. They can focus on Inventor. They don't have to go through the manual processes that Rob has shown in terms of adding the metadata and the MBS codes and all that sort of stuff. Why isn't it just automatic at the click of a button? Really excites me, and I'm really passionate about making sure that you guys are automating as efficiently as possible. Last thing I want to end on is just a bit of an advert, really. Not only Robin has mentioned our our channels, please go and subscribe to our YouTube channel. Everything that we do is on YouTube. We've done several webinars in the past on Inventor, on BIM and on Revit and on iLogic and automation. The future webinars that we've got coming up, we've got a weekly one called the M Word, which is on every Thursday afternoon. We're also doing more specific, longer webinars like this one on the 2023 updates, and we're also going to be looking at payment plans, so how to spread your monthly costs, make it a little bit more affordable for Autodesk licensing. And really excited to tell you that very shortly, please watch this space, please watch our social media channels, because we are going to be doing some live events in July. We're just putting the final pieces of the puzzle together to put them on our website. Please go and watch our social medias and come along to some physical events that are going to focus primarily on all things automation. So whether that's automating your BIM content, like we've just said, automating your design process, your sales process, your manufacturing process. Really excited to bring you, and be really great to actually meet some of you for the first time in a little while. So without further ado, thank you for your time, and we will see you on our next webinar. Thank you for joining us today. Take care.